Hey everyone, and welcome. Today we're going to jump straight into a really cool corner of A-level pure maths. We're talking about the binomial expansion, but with a twist. What happens when that power n isn't a nice, neat positive whole number? Well, that's where things get super interesting, and honestly, a lot more powerful.
Okay, so here's how we're going to tackle this. We'll start with the main formula, then walk through an example. After that, it's all about practice. We'll hit some exercises, some more advanced problems, and then finish up with some exam questions to really test our skills.
Right. First up, the core formula. Think of this as our mathematical toolkit for today. Everything, and I mean everything, we're about to do hinges on this one thing.
So here it is. This is the magic formula that lets us handle those messy fractional or negative powers. It's awesome, right? But, and this is a huge but, look at that little condition right there. The absolute value of x has to be less than 1. This isn't just a suggestion, it's a hard rule. Why? Because if x is too big, the terms in our expansion just get bigger and bigger and, well, they fly off to infinity. The whole thing breaks down. So we've got to check this every single time.
Okay, enough theory, let's see this thing in action. We're going to grab a worked example straight from the textbook and pull it apart, piece by piece, so you can see exactly how it works.
All right, here's our first challenge. We've got this fraction, x minus 5 over 1 plus 2x, and the goal is to find the coefficient of x cubed. Now, you might be thinking, hang on, that doesn't look like the formula at all. And you're right. We can't just plug this in. We need a strategy.
So what's the plan? Well, our formula needs something that looks like 1 plus something to a power. A fraction isn't that. But remember your index laws. We can rewrite division as multiplication by a negative power. So the first big move is to change that fraction into x minus 5 times 1 plus 2x to the power of negative 1. See? Now that looks a lot more manageable.
And here's how that plays out. First, we do that rewrite we just talked about. Then, we focus just on the bracket part, the 1 plus 2x to the minus 1, and we expand it using our formula. Super important, notice how the x from our main formula is actually 2x in this problem. You got to be careful with that. Once we have the expansion, we simplify it down, and then for the final step, we bring back that x minus 5 and get ready to multiply.
Okay, now here's where we work smart, not hard. We could multiply out that entire thing, but who has time for that? We only want the x cubed term. So let's think, how can we get an x cubed? Well, we could take the x from the first bracket and multiply it by the x squared term from our expansion. That works. Or we could take the constant, the minus 5, and multiply it by the x cubed term. That's it. Just those two combinations matter.
And when you do that, you get 4x cubed plus 40x cubed, which gives us a final coefficient of 44. Boom, done. Super clean, right? All right, so we've seen how it's done. Now it's time to get our hands dirty and actually do some. We're going to jump into the exercises, starting with question 5 to really lock this in.
Okay, question 5. Expand 2x minus 1 to the power of minus 3. Right away, you should spot the issue. The bracket starts with 2x, not 1. Our formula needs it to be 1 plus something. So what do? The first step is always to get it into the right form. We have to do a little algebraic jujitsu first.
And here's the trick. We can factor out a minus 1 from inside the bracket. That flips it around to minus 1 times 1 minus 2x. Perfect. Now we can use our formula, just remembering that our y this time is negative 2x. This is where you have to be so careful with your signs. Once you've expanded the bracket part, you just have to remember to apply that overall negative sign you factored out at the very beginning. Easy to forget, but crucial.
Okay, next up, question 6. This one's a little different. It's not about crunching numbers. It's a show that question, which is really a test of, do you understand the rules of the game? We need to prove why the expansion of 1 plus x to the half isn't valid when x equals 3.
And the whole thing comes back to that one golden rule we talked about at the start, the validity condition. Remember? This whole expansion business only works, it only gives you a sensible answer if x is small enough. That's the key to this entire question.
So let's check. The condition is that the absolute value of x must be less than 1. The question gives us x equals 3. Well, the absolute value of 3 is 3.
And is 3 less than 1? Nope, not even close. So the condition fails and the expansion is invalid. Simple as that. It's a quick check, but you can see how important it is. All right, on to question 8. This is a cool one. It's kind of a reverse problem.
They give us the final answer, this negative 3 plus 12x, and we have to work backwards to figure out what a and b are. The game plan here is to expand the left side and then match up the pieces with the right side.
So first things first, we turn those fractions into expressions with a power of -1. Now notice the answer only goes up to the x term. That's a huge clue. It means we only need to expand our brackets up to the x term as well. No need to calculate x squared or anything higher. Once we do that, we collect all our constant terms and all our x terms. Then we can just say, okay, all the constants on the left must equal the constant on the right, and all the x coefficients on the left must equal the x coefficient on the right. And just like that, you've got a pair of simultaneous equations to solve.
And once you solve those equations, you get your answers for a and b. It's a really neat method for what looks like a pretty intimidating problem at first glance.
Okay, let's ramp up the difficulty a bit. The next couple of problems are more advanced. They're going to layer a few different ideas together and really make us flex our algebra muscles.
So, question 10. This is a classic. We've got this big expansion, and we're told the coefficient of x squared is -15. Our job is to find a. This is definitely a multi-step process. We have to expand the bracket with the power, then multiply everything by 3 minus 2x, then hunt down all the bits that make an x squared term, set their coefficient equal to -15, and solve. Phew, let's do it.
Step 1. Expand that 1 plus ax bracket. We only need to go up to x squared, since that's what the question is about. Then we do that work smart thing again. How do we get an x squared term when we multiply? Well, we can take the 3 from the first bracket and multiply the x squared term. Or we take the negative 2x and multiply the x term. We add the coefficients from those two products, and that's our total coefficient for x squared. And what do you know? The equation we get turns out to be a quadratic.
Solving that quadratic is pretty straightforward, and it gives us two possible answers for a. That's important. Sometimes you get more than one valid solution in these problems.
Okay, last big exercise before the exam questions. Question 11. This is another one of those compare the coefficients puzzles, but this time we have to find two unknowns, both a and the power n. The strategy is pretty much the same. We write out the first few terms of the general expansion for 1 plus ax to the n. The x term's coefficient is just na. We know that equals -24. The x squared term's coefficient is that n times n minus 1 over 2 all times a squared. We know that equals 384. So now we've got two equations and two unknowns, n and a. From here on out, it's just a good old-fashioned simultaneous equations problem. We can rearrange the first one to find a in terms of n, plug that into the second equation, and solve for n. Once you have n, finding a is easy, and after all that, we can finally find the x cubed term.
And there are our results. After all that work, we get a equals 8, n equals -3, and check out that x cubed term, minus 5,120x cubed. That's a big number.
Okay, we've covered the formula, we've walked through examples, we've tackled some tricky exercises. You're ready. Let's finish up by looking at some exam-style questions. So this is where I'm going to ask you to pause. Have a go at these problems yourself. It's the best way to see if you've really got it down. Try them out, and then when you're ready, unpause and we'll check the answers. So how did it go? Here are the final answers. Hopefully you found that even though they look different, they all boil down to the same core skills we've been practicing this whole time: getting the expression in the right form, applying the formula, and being super careful with your algebra.
And I want to leave you with one final thought, a little teaser for why this is so cool. This isn't just about passing an exam. This stuff is actually used to approximate things. Think about it. How could you use what we've learned today to find a value for, say, the square root of 1.02? How could you write that in the form 1 plus x to some power? If you can figure that out, you can get a really good estimate without even touching a calculator. And that's when this math